In this demo, I'll explain how to do volume calculations. If you have not yet watched the videos on creating digital terrain models, contouring, 3D viewing, and slope intercept calculations, I'd like to recommend that you do so first. For this demo, I'll use the drawing used in the demo on slope intercept calculations. This drawing contains two terrain models. The first terrain model, terrain 1, or existing terrain, is the original terrain as measured in the field. Another terrain model, called design walkway, is what the terrain will look like after a little walkway has been put in. The 3D view for each of these terrain models are as follows. Here's my original terrain. And here's what my terrain will look like after I put in my road. What's important here is the volume of earth that I will need to move to be able to put in this little walkway right here into this terrain. The first thing I need to do is, before I can do any volume calculations, is tell Pythagoras which particular area needs to be calculated. I create a polygon to define the area. There you go. This particular area is what's important to me. There. That polygon right there. I hold down the O key on my keyboard and I select the polygon. Next I select the menu option, Calculations, Volumes. A dialog box pops up. In the particular example where I want to know what the amount of cut and fill volume is needed to put the little walkway in, I select the second option because I want to calculate the volume difference between the existing terrain and the design. Existing terrain minus design. Calculate, and there you go. The bottom of the dialog box shows the calculated cut and fill volumes. As a side note, instead of calculating the difference in volumes between two terrain models, I could have also simply calculated the volume for one particular terrain model as compared to a fixed elevation of, say, 5 feet or something. That would be as if I were simply flattening out the terrain to a certain elevation. Getting back to my original volume calculation, I'd like to say a few words about this section right here. Number of cross-sections. As a default value, Pythagoras used 10 cross-sections to do the volume calculation. Since Pythagoras uses the average end area method to do the volume calculations, that means that it took the first slice, it took a first slice, or cross-section, calculated the area of that slice. Then it took a second slice, it calculated the area of the second slice, added the two areas and divided by 2 to get the average area. And finally, this area was multiplied by the distance between the two slices in order to obtain the volume between these two slices or cross-sections. The same thing was done for each slice or cross-section along the way. So going back to my volume calculations, Pythagoras shows that the distance between each slice or cross-section in the dialog box right here is 6 feet. If I feel that's not accurate enough, I could simply tell Pythagoras to increase the number of slices or cross-sections to, say, 100. I hit the Tab key, and now each slice is 0.67 feet wide, or 500, or whatever. Calculate. I could also simply tell Pythagoras that I'd like each slice to be, say, a half a foot apart. That results in 134 slices. There you go. By the way, did you notice the speed at which these calculations were performed? After you've done the volume calculations, you can save your result to a text file and then import it into an Excel spreadsheet to view the volume results for each cross-section. This concludes this demo on volume calculations. I hope it provided you with a few helpful tips.